So what we have before us is a QG with a Wingroad Y11 with a QG15 cable type. Right? It had some issues with the fuel pump connector. We fixed that, and now it's having a rich condition. If you check the fuel trim, looking at 80, 79, 77, that's supposed to be around 90. Right? The engine idling high. Right? If you watch the OP sensor, it's oscillating between rich and lean. So we're finding stoichiometry with minusing about 20+% fuel. So we're going to check the fuel pressure and see if it overpressuring, so we'll know if the regulator is sticking. Right, so we already released the fuel pressure by taking off the relay and line it idle. Right, so there's the fuel line that coming from the pump. This one is the return, so we put in the gauge on this line here. Right, so the fuel gauge hook up. You go on in there from the T into the fuel rail. There's the gauge there. Right, so we go in and turn on the fuel pump. Right, fuel pump on, making sure we have no leaks. Right. Right, we're getting around 60 psi. Right, so I'm going to start and see how much that's dropping down to when the vacuum pull. Right, so we have around 70 psi. We're supposed to be at around 37, 40 around there. And when the regulator close, it's supposed to be at around 50, something around 70, definitely too high. Alright, so we take off the return side from the regulator, right, and we go in and pressurize the rail briefly to see if we getting fuel on the return line. If none, well, then we know either the regulator not working or the line plug. And that's the regulator there. Right, so we put this bottle in case if we catch anything. Right, and now we go in and turn on the. We're using the actuation and the bidirectional. The bidirectional scan tool to turn on the fuel pump relay. So we can turn on the fuel pump. Right? Execute. Pump on. No pressure. Right? And we gain about 60 psi. Right? 58 point something. Nothing coming through on the return. And we gain pressure on the inlet. Right, so we stopping it. Right, so fuel pump off. Right, and we still holding some pressure. Right, so I release that pressure and then take off the regulator from the rail to see where is the problem. I blow air in this line, the return line in the tank, that clear. So we know that is not the problem. Alright, so I'm going to hook back up that return line and then work from the regulator side. Alright, so hook back up the regulator, the return line, go back on the hose clamp. And then we'll test again. Alright, so we're checking again here. We're getting vacuum on the line for the regulator. So we know that that line not clogged. Alright? Check it in. 70 PSI. Too much. Alright, so I try to turn on the regulator. The screws and then push up. Alright, so that is the verdict there. Doing to further confirm, I'm using this canister where it's used to clean the injectors. Pressurizing it to around 40 psi. Right, it has gasoline in it. And we're going to see how it idle. Right, so the fuel pump disconnected and idle drop normal. Get the scan tool and we'll see how much the idle dropped it. We down to about 1100 RPM from 1300. Right. So notice the alpha was 70 something. Now we are at around 93, 92 around there. Right, so now we'll try a throttle reload and see. Alright, so we at it again, day 2. We're going to try and resolve the fast idle issue. Alright, so we're taking off the intake box, we're taking off this line so we could get access to the throttle body to take out the throttle body. Alright, so the throttle body off. That is the idle air control valve there. But when I'm trying to actuate it through the scan tool, it's not moving. Right, but the jack was looking kind of bad. Right, so there's the scan tool here. Right, scan tool, quick up, 70, no movement. Right, so I'm going up, no movement. No movement, 80, 90, no movement, down, no movement. So that's supposed to be going in steps, right? What I would do is check the voltage to make sure we getting correct voltage on pins 2 and 5. Supposed to get 12 volts on pins 2 and 5. So we're down to 0, no movements. Right, so I'm going to check the voltages on pins 2 and 5 to make sure we're getting voltages. So we're hooking up the multimeter. We're just checking the yellow pin in the ground. Right, touching it on the positive to make sure we're getting a reading 12 volts. Right, so we're just putting the multimeter where we could get a little visibility there. Right, so pin 2, 12.4, right? 12.34. So we're going to try pin 5 now. Right, pin 5. Right, so we're getting the 12 volts coming in from the relay. Right, so we're going to check all the individual coils, because there's basically a stepper motor with a center tap. That is the ground side switch from the brain to cause it to increment. So we're going to check the voltages on the coils. Right, so we're testing there, and the motor getting hot. If we lucky, it's not the brain not blow, but the two top, we getting the 12 volts, right? So that is this and this, we getting the 12. But at the two bottom, that is ground, which not supposed to be. So I'm hoping it's not the brain, not the driver and blowing the brain. So I'm going and disconnect it. Alright, so there's the state of the jack here. Alright, so there's the state of the jack. Right. So what we see happening is when we same pins that we was getting the 0 on, when we check for continuity, right, we getting continuity on the body. Not supposed to happen, right? Right, so we getting continuity, these two. Not supposed to happen. Right, so if we check the good 2, no continuity. Right. Alright, no continuity. So that could mean two things. Either the drivers on the brain shorted out, or it have a short in the harness, which I would prefer is the situation. Right, so now for the moment of truth. Brain out, disconnected. Right. So we in. Hey, relax yourself. Right. So we touching. Nothing, no continuity. Right. That beep is not continuity. That is just the multimeter deciding to beep. Again, next one, no continuity. Bad. Good in the sense that it not short to the chassis, but bad in the sense that the brain is what short, the drivers in the brain short. So after get a brain. Alright, so if you're interested in buying a brain, there's the brain that you're looking at. Alright, unfortunately, drivers in the brain bad for the idle. So without that, we can't do no reloading. Right, so the idling down to about 825, 850. Right, so this again, this rich condition, this 85, have to do with the fuel pressure regulator. So once that's sorted out, that will go down. But the verdict is we have to manually set the idle air control valve to get it to idle because the driver's in the brain blow. So it's either you get the brain repair or you work it as is or you buy a new brain. Right? But it's up to you. Alright, so that is it for the road with respect to the idle. We down to the 800s. Right. Fuel trim again had to do with the fuel pressure regulator. Right. Everything back in our gear. Right, so in addition to manually adjusting the idle air control valve, right, we put in this screw here so we can get some fine tune on the idle. Right, but this is not supposed to be interfered with because then you have to calibrate it to make sure that the closed throttle and the open throttle within 10, I think is between 0.05 millimeters and 0.15 millimeters, right? That is your tolerance. So you have to do the calibration with that if you adjust that. Right? So that is it there for the hour. Right? So that is a temporary solution until customer decide what they're doing with respect to the brain, if they're changing it, if they're going to repair it, if they're running it just as is. Right, so oil change. We're going to check the brake fluid to check the moisture content. Right, so we're going straight up to the red. So this brake fluid needs to change. More than 4% moisture content. And even if you look at the brake fluid, it's looking like it's full of corrosion. So this needs a flush. Alright, so we're just checking again. 4%. More than 4%. So need to change.